Hello all, I'm Niranjan and today I'll be talking about topic which is Introduction to Application Security. This topic is pretty hot, like it's been a decade for me being in this area, but still I see this is still alive and this is still relevant in the market. And I see many of the folks like who are looking for career change or they are looking for new opportunity. They usually do me reach me about like what is application security, how we can end our career in this, how we can what should we learn to get into application security. So I'll be talking about some of those stuff in this talk. So be with me and let's get started. Okay, so before I start, like I would like to give information about myself. So this about me, who I am, and some info about me. Okay, so let's get started. What is application security, right? So, in a layman term, like we have a definition on the screen, but if you ask me in the layman term, how would they understand, right, this topic? So it's like it's a very simple process where you identify bugs in the apps before they go live or before they are being served for their work, right? Before for the purpose. So it's a process where you identify bugs in the maybe in the code, maybe in the GUI, maybe in the software composition, or maybe in the configurations, right? So all those things just to find flaws in the app so that they are more secure, they are more robust, and so that we identify all those bugs before any adversary identifies and take advantage of these and those and convert them into 0 days, right? So that's basic info about AppSec, but how it can actually be achieved, right? So there are various ways, like AppSec is being split into like terms of testing, like so it has many testing you can see on the right side, like it can be achieved through SAST, DAST, AST, SCA, and PT. So I'll be going through each of these. So be with me. Let's move on to the next stuff. So before I come to security testing, I would like to talk about SDLC. Okay, so what's SDLC? So anything like any product is being developed, it has its own life cycle, right? So it might have been planned, then it might have been designed. Then once the design of the product was ready, then it was started being developed. Then some sort of testing might have been performed on that. And ultimately, after all those testing, it has been deployed into the environment where people can use it. And after usage, like if there's a maintenance required in that product, like it goes through a loop, feedback loop where people can provide their inputs and that product is updated based on its maybe regular intervals. So all this thing comes as a part of any life cycle of any product. Same goes to software. So software also has its life cycle. It has to go through all the similar sort of phases like planning, design, development, testing, and so on. So now comes to the security of that. So people say like because there's always a myth about security. People say like, okay, we developed a product, let's append something in the last and create as a full product with the security, right? So security cannot be appended in the last or like it should be embedded as a part of process. So process it has to go through each phase. So security cannot be have it's not like an add-on. It's more like if you implement as a phase wise, you can achieve better results in terms of security. So when you implement like security as a part of each of these SDLC phases, so you have various security services being introduced in each phase. So some of them are you can see on the screen, like maybe when you're planning, when you're gathering the requirements from customer for the product, or maybe from the team who have a requirement of generating or creating this product. So you perform the gap analysis or risk assessment during this phase. And once you have your design of the product being it's ready, you can perform the threat modeling because in this phase you may require design diagrams or like low level diagrams or high level diagrams of any of the software components what you're building. And once your design is ready, you can go for development. And once you start writing the code, when you start coding the application or service, whatever you're providing, you look for you have a security service over there like security code reviews. So where maybe analysts come and identify the security code, code flaws and report it to the development teams, and it can be identified in the coding phase rather than it's being identified in the later phases, because the cost of the bug which is identified in the later stage is more than if it's being identified in the earlier phases, or maybe in the current phase. So once your code is ready, it has an app being running. It has a GUI. It might have a GUI, or it might have thick client, thin client, whatever it is. It has a running version of the app being ready, right? So in that phase, you can perform the security testing like DAST, dynamic application security testing. You can also perform maybe VAPT, vulnerability assessment and penetration testing. And once your code is being deployed, right? So there could be other checks like DevSecOps comes in picture, where you implement certain sort of tools which check for maybe security flaws once the deployment's happening, and block the codes if it has any security warnings or like violations over there. And once your code is being deployed annually, like because security keep changing every day, right? So that you have to you have to make it evaluate the security of the system every maybe now and then, right? Maybe based on your regular intervals. So that comes in monitoring and maintenance phase, where you monitor the apps and where you maintain the app. Like maybe if there's any input or if there is any improvement in the app, you have to create a more features. You have to what do you say? Correct the existing ones. So you have to do all this as a part of secure SDLC phase. So this is all about SDLC and secure SDLC. So I'll move to next. So it's like I was talking about these terms like in earlier slide, where SAST, DAST, SCA, and Pentest. So it's like each has their own advantage, because like you may ask with a question like which application security testing is applicable to me, or which I should do it. So sometimes like the mature organizations do all of this because they have their own each of the service have their own disadvantages and advantages. So typically all, but yeah, if you have a like foundation or you have a restriction, you cannot do all. You have to do at least choose some of them and some of these, and perform on the environment or maybe service or product what you are testing. Okay. The first one is SAST, right? SAST stands for Static Application Security Testing. So it means you have a code with you there for the app which you are testing. So in that, you scan the code. If you have a scanners available, like if you don't have scanners available, you can go for like search word based a source code analysis, or maybe line by line code analysis. Those are tedious, but search based analysis is pretty much faster. Like where you can we have a grabbing tools where you can grab by keywords and get onto the piece of the code, and try to identify some of the vulnerabilities which are known to the world. uh, I'll talk about the list, like where you can identify those checklists, like where those vulnerabilities exist, like known vulnerabilities, and you can test against those your apps. So that's about SAST. So let's come into the DAST. DAST is all about dynamic application security testing, where you have an application in running mode. So maybe when you have a GUI, when you have a app is running in a running state, like you have a UI running, you have a web app, or maybe it's a thick language in running state. So you can test those in a running environment. And so that provides definitely higher accuracy in terms of quality of the finding. Because with SAST, if you run through maybe not the manual one, but the automated one, it generates a lot of false positives. So if you see like DAST, it has advantage like you go into the GUI and it identify flaws. So the possibility of the quality of the flaw you have found is far better than the SAST. Coming to the AST, so AST is you can assume it like a mixture of both like SAST and DAST. So it's interactive application security testing, where you have uh, SAST and DAST being performed at the same time. Like there are scanners like which can perform all this activity at the same time, because what happens like they both things are run in parallel. So there are tools like which actually perform code review. Along with it will compile the binary running and monitoring the state of the that particular binary or like the app which is being run, and on that basis it identifies the security flaws. So the quality again increases in terms of the like the efficacy of the finding is increased in this space, but they are pretty much, I think, costly tools. So but you can do the both individually if you have budget or good environment, or maybe a budget for all these things. You can uh, uh, perform this IAST. SCA is like software composition analysis, where you, because in this world, like no company builds the software which is 100% like they are building of their own. Sometimes they have to inherit the dependencies from other libraries like which are already being built. So it's like code reuse thing. So just to reuse the code, we have to make sure like whenever like code is being inherited from the third party library, which could be vulnerable, maybe not, it's not vulnerable today, but maybe if the support for that library goes off, and it can come up with some vulnerability in future. So you are inheriting some of the risk through that way in your apps. So that's the analysis like which being done as a part of SCA. And so pen testing is like it's full coverage, like it's being written over there. So it's like you perform end-to-end testing of the app and identify all the uh, flaws in that through the GUI, maybe through threat models, or like, and you go with the approach of assuming risk, right? There's assuming breach, like the app's breached, like what could happen next, right? So in that way, that's sort of red teaming sort of activity which comes in picture over there. So each of his service has its disadvantages and advantages over other. So that's about the type of testing, which one to choose in which environment. Okay, so when it comes to application security, like there are vulnerabilities which maybe analyst or security professional go and find in the apps. So these are some of the common flaws like SQL injection, cross-site scripting. There could be misconfiguration. So we all know like what's SQL injection, but for namesake, like it's a flaw. Like you need to have a database. Like if it's a prerequisite, and if you have an app which is talking to a database, then if that the user input is not being sanitized, then it can could potentially lead to SQL injection there. So identifying all this as a part of SaaS, as like it's pretty much I'll be sharing in upcoming videos in depth, like each of these flaw, but just for the uh, keeping it simple for understanding as an introductory phase, like these are some of the web security threats, like or web security vulnerabilities, which analysts find as a part of these security testing assessments. Okay, so best practices, right? So there's a problem in what's the root cause of these issues, right? So majority of the root cause like comes as a part of input validation. So whenever you are expecting input from a user and changes its trust boundary, coming it from internet, which is not trusted, and coming it to your web server, a trusted environment, it should be validated. So the majority of the flaws arises because these inputs are not validated. And the others are like access control flaws, like maybe the privileges are not minimized by coding or by and when the app is being developed. So this is about it. And the other one is like encryption. So when you are sending your data, you don't have implemented proper encryption mechanisms, like maybe when your data is being sent over internet, like on a HTTP traffic or some like that traffic, network traffic, it's not encrypted. So there are ways like you can use SSL, TLS, and latest version of these to protect your information at transit. And if you feel like you're storing some data in your database or maybe in your environment, you should make use of good encryption algorithms, like which provides a way to store those data stored safely or like securely in your environment. So these are some of the best practices. Uh, Coming to tools, like so there are tools like which comes in picture when you do application security testing, like Burp Suite, like where you intercept the traffic, what's going on between your browser and a server, how's the communication happening. So it happens on the HTTP protocol, and but what requests and responses are being exchanged, you can easily identify using some of the proxy tool like Burpsuit. And there's another OS app like that has many features, like along with proxy, it has scanning feature, and you have SonarCube. These are paid tool. Um, that's for use for automated testing of your app. So there are many other tools. These are some of the, just for simplification, I have put few, but there are many more. And coming to importance of secure coding. So so the major flaws like which are when you do a root cause analysis of any of the flaw, like what you have found, like majority of the time you'll find like the flaw is being maybe generated because there was some misses happened at the time of coding, right? There was no proper validation, there was no proper configuration or of any of those parameters, or there is no proper checks being performed, or the when the output is going to the web browser, it's not being sanitized properly, so that many of those issues occur because of these things. So uh, that's the reason like there's secure coding is very important in this era. And because of this AI and stuff, like there are various ways you can validate your code, whether you have when you have coded the product, like whether it's actually secure or not. But there's again exposure, right? So if you have tools with respect to GenAI in your environment, you can easily identify some of the best coding practices. Like whatever you have coded, you can ask ChatGPT or someone in your environment to see if your code is secure. But those are customer coded thing. You cannot check it on public ChatGPT model. So you may have to generate your own model inside and test your code on that. The, the future is near, but on this, but we are moving toward that. So secure coding is really important. How you do it, it truly depends on the best practices or like secure coding practices you have implemented in your environment, and that certainly reduce the risk of exploitation if you start coding securely the app. Okay, so application security framework. So I was talking about the checklist, uh, how would I know like what sort of vulnerabilities are there, and there are a couple of frameworks like OS Top 10, Zen's 25. They publish their OS Top 10 like list every 2 or 3 years by considering the various factors like what risks in the market, what are the ones which are being exploited, and why. Based on those reviews, they keep changing some of these OS Top 10, and they contain the flaws like top 10 critical web application security risks. And SANS also has its top 25 where they offer the list of these dangerous software errors, what happens. So I'll be talking through all these two frameworks in upcoming videos, and we'll be sharing with you folks. So that's it for today. Thanks for watching. If you have reached till here, if you like the video, if you see this is having good information or you might have learned something out of it, do follow me using the same YouTube handle, Simplifying Security, and I'll be coming up with more content. Thank you.